It's time to begin our masterclass on building a blockchain application on Corda. We have with us Mr. Ashutosh Meher, Developer Evangelist R3. I would request all the delegates to please keep posting their questions in the chat box and we will pick up a selected few towards the end of the session. Without any further ado, I would request Ashutosh to kindly take the floor. Over to you, Mr. Meher.
Yeah, thank you so much, Aparna. So as Aparna mentioned, I am Ashutosh. I'm a developer evangelist at R3. So first of all, I'll start with a word of thanks to IAMAI for organizing this masterclass, and um, and I hope it will be really helpful for guys who are starting out their journey on blockchain or Corda in general. So what we'll do today is we will go through some of the basics of Corda and try and understand how you could build a blockchain application on Corda. And finally, I'll also do a short little demo for you to see how things really work in Corda, right? So let's get started then. All right. So before starting on, here are a few references which will be pretty helpful for you, pretty handy when you start doing your developments on Corda, try to build your applications on Corda. So a few of them are our YouTube channel where we regularly post videos, technical and non-technical as well. We have a free training site, which is where you can go and have a kind of a streamlined approach towards learning. So it starts with easier things and then goes into more and more complex parts of Corda. We have a public Slack community which is growing at a good pace. It is already 9,500 plus developers in there, so a great place for you guys to join in. Documentation. So if you want to have a look at any particular feature of Corda, I want to look about anything or anything in particular in Corda, it would be available in our official documentation, which is at docs.corda.net. And Corda is open source, at least the open source part of it. So you can find the entire code base at our GitHub page. And then if you want to email us, that is the DevRel team, here is our email address on the screen. And as well as if you're a Twitter guy, you like to tweet, then we have these different handles which you could use, which is at the Corda blockchain and at the rate inside R3. Also, you could choose to use one of these hashtags, which we have. All right, so with that aside, here is the broad agenda for today. So we'll just do a brief intro to Corda so that you understand what Corda is before we look into how to develop an application on Corda. We'll talk about a little bit about the Corda node, the notary, and how consensus occurs in Corda. And then we'll go into Corda apps. So Corda app is basically your application, which is what we developers generally develop, and then we run this application on the Corda platform. And finally, I'll do a demo of running a Corda app, already built Corda app, so that you get a feel of how things work on Corda. Right. All right. So to understand Corda, we will really have to look at how things are in terms of traditional blockchains and what we have tried to change and why we have tried to change them. All right. So if we look at traditional blockchains, what are the different kind of things that made it not very suitable for making it business ready, right? So there are a few things which I have pointed out here. There are many more, but these are probably the most prominent ones. So initially, you don't have a good identity. So if you look at any blockchain platform, any public blockchain platform which was out there traditionally, you would not see a real identity. What you would really see is a pseudo-anonymous key, which is what we call as a public key. And you can't really do business with people if you don't know who they are, who you are interacting with. On the other end, all you know is a public key, right? So that's pretty difficult to do business. And then the second part of it is privacy, which is basically um, how you share your data, right? So with blockchain, with public blockchains, as the name itself is public, right? There's a lot of stress to transparency. So you just put any data onto that blockchain, it just becomes available to everyone in the network, which is certainly not a great use case or a great feature for business-oriented applications. You don't want all your clients to know about some private transactions that we're doing with one particular client, which could lead to a disaster, obviously. So that's something which we need to improve on. And then we have the problem of finality. Well, there is no finality as such. If you look at traditional blockchains, so for example, if you take an example of something like a Bitcoin, right? You don't really know when your transaction is going to be completed. It might be 1 hour, or it might be 15 minutes. It might even take days, but there is no real deadline onto when your transaction would be completed. Now that's because of reasons in terms of how mining occurs and how blocks are added. We'll not go into the details of that, but that's a problem which is prevalent. So you don't really know. The finality, you could say, is more or less like probabilistic in nature, and it's not really you can't put a line when your transaction is going to be final. So that's a problem. In business cases, you need to have that sort of a deadline that you could say this is the deadline when by which the transaction needs to be completed. Right. And finally, but the last one, but not the least, obviously, is the ease of use. So this is which relates to developers. Basically, when you talk of any new blockchain platforms, right? So people will have to learn. One is the blockchain platform itself, the entire new technology they'll have to learn, and then they'll have to go through all these different tools and protocols which would be required to develop applications on those platforms, which certainly makes your learning curve quite steep, which is something not desirable. Right. So these are the issues which we have tried to cover with Corda, and then try to make it more suitable for businesses to run their business on Corda. Right. So first of all, what we did is, unlike a public blockchain platform, Corda is a permission network. So basically, you cannot just join Corda network by downloading the Corda software. You will have to go through a process of KYC, which will allow you to, the KYC is again done by a particular entity called as the doorman, who will then provide you access to the Corda network, right? So um, so that's what happens. And in this process of the entire KYC, what happens is you have to basically provide your legal identity in terms of your legal name, and then that will be updated in the network, so that others can know you not just by your public key, but also by a legal name which you have provided during the onboarding process. So that's where we solve the problem of identity. So it does provide you with a strong identity. You know, you don't anymore do transactions with anonymous people. All right. Now, the second problem was privacy. So to take care of that, Corda doesn't do global broadcast. There is no thing like sharing the data with everyone in the network, right? So the communications or the sharing of data is always point to point. So we call it as a mind your own business kind of a blockchain platform. So basically, you don't have to look at details of transactions happening with other parties which you're not concerned about, right? So if there is a transaction between two people, say Titan and Bay here, so basically the vehicle you could see, which is the asset that is being transacted, is only available with Titan Tech and Bay Transcorp after this transaction is completed. While Acme being in the network will have no idea of any such transaction happening. Right. So finally, the thing about finality is, so we handle it by having a logical component, which I say is a note, which we could say is a notary pool. Well, the notary pool is basically a component whose main purpose is to prevent double spend. And by double spend, I mean, if you take a look at this particular transaction where Titan has sold this vehicle to Bay, so notary will make sure that he cannot sell it to Acme again. Now, if he tries to sell it to Acme, if there is no notary, then probably Acme will accept it because of the point-to-point nature. Acme doesn't know that there was a transaction which happened between Titan and Bay, and the car has already been sold. So to help Acme to identify such kind of issues, we have something called as a notary or a notary pool. So it could be a single node, or it could be a pool of nodes running any kind of consensus algorithm, which is again pluggable. So basically, you go through this entire process where all your transactions goes in a particular workflow, and then finally it goes to the notary where it is checked for double spend, and then if it's not a case of double spend, then it is finalized. So when it is finalized, I say that once it has reached the notary and it has been finalized, there is no probability in nature. There is no probabilistic finality that's coming in nature. So basically, your finality is fine. Your transaction is final once a notary gives a go ahead that the transaction is completed, it is finally completed. So there is no rollback coming in here, right? And finally, the thing of where we wanted to make sure that Corda is easy to use, what we have done is we have implemented already existing technologies. And we haven't tried to go ahead and reinvent the wheel, but what we have done is we have used already available technologies like Java, DBMS, and ActiveMQ, which is basically used in almost any enterprise applications. So other than the probability of making it easier to use, what it also provides is it gives you better integrations with existing systems, because we are running on the same tech stack, right? All right, so there we go. We have been able to solve most of our problems that we had, which is the problem of finality, the problem of identity, privacy, and also ease of use. Right, so let's move on to the next section here. So if you have any questions, just put it on the chat, and probably I'll be able to help you guys with that. Right. So next section is where we will talk a little bit about the Corda node, Notary, and the consensus of how it works in Corda, right? So what exactly is a Corda node, right? So it is the entire thing. This is the real deal here. So Corda node is a JVM runtime, which runs on the JVM environment, and each node has a unique identity. This is what I talked about, the strong identity, right? Every node will be referred to as by a unique legal identity. You can think of it as a black box, which allows developers or operators to sort of not worry about things like the low level things like your key management, your storage, and your communication, messaging, and stuff. So it'll all be taken care by the node. All you have to do is call certain easy to use APIs to make sure that you're able to do a particular task. Now, the node itself will provide you with two interfaces to interact with the outside world. So you can think of it, it has a network layer, which will be more for P2P communications in terms of communicating with other nodes in a particular network. And then there will be an RPC layer, which is basically the interface to communicate with the node operator. And the node operator is the one who will be issuing commands to the node to do a particular task. So we'll be using the RPC layer to do that. Right. So your Corda node can again have multiple Corda apps. Now, Corda apps are applications which are deployed on your node. So the Corda node itself doesn't do much unless you have a well-written application which will basically run on your Corda node. So you could have multiple applications, something like you could run a trade app, you could run insurance app, and whatever. So you could use any number of applications that you could deploy on your node, and then you can run your businesses with that. And to deploy or install this particular Quad app, it's not a very so the word install is something which makes it sound like very techy, but I don't think so. But I don't think it's really that difficult. All you have to do is put it in a particular folder. So when you install Corda, so it will provide you with a particular path where you need to put your Quad apps, and once you have put it there, it's the node will automatically pick it up, and you can then start using that application. Right. So the next thing that we're going to talk about is consensus. So with consensus, if you have come from a blockchain background, you might know that consensus is the process of basically coming to a conclusion about the nature of a transaction, or whether it is a valid transaction or not a valid transaction, right? So you might have heard of consensus in different blockchain platform, but Corda has a different view to consensus. It doesn't depend on a single consensus type. We have two different types of consensus here. So basically, one is the uniqueness consensus, which is we have already talked about in a notary section. Notary does the uniqueness consensus, which is also called as notarization. So it is where you check whether your transaction is a case of double spend. But notary doesn't really check whether the content of the transaction are correct or not. Notary will just say that this particular transaction is not doing a double spend. So how would I know if the content of the transaction is correct? So for example, in the case where we did the vehicle thing, notary doesn't know that there is a vehicle which is getting transacted, but what he knows that this vehicle or this particular asset, whatever asset it is not being double spent. But how do I make sure, is it the real vehicle? Is it even a vehicle, or is it the actual vehicle which I'm expecting? So all these kind of validity checks have to be done by the individuals who are available in the transaction or who are transacting actually, and then they have to come do the validity consensus by running a particular business rules which are installed on their nodes. These business rules, we call them contracts. So we'll talk about that while we move ahead. So generally, all your transactions first go through the validity consensus, and then it will go to the uniqueness consensus. So a transaction is valid only and only if both these consensus are deemed the transaction to be valid. All right. So next thing, we'll dig a little deeper into Notary. So Notary's primary purpose is to check for double spend. So basically, if you look at the Notary, it doesn't really look at the content of the transaction. So there is no privacy breach here. What it does look is the structure of the transaction in terms of transaction hash and basically we follow something called as the UTXO model. If you've been into blockchain, you might understand what a UTXO model is. So basically, it means that every transaction will have inputs and outputs, and the output of a transaction is then pushed into the input is then pushed as an input to the next transaction. So basically, that's what UTXO is. So Notary just look at that structure, the UTXO structure, and it doesn't really look at the content of the transaction. So it doesn't know what's really the content that is getting or what is really the content that is being transacted, but it knows that there is a transaction is happening, and then it knows how the transaction is originating, what is the input and output of the transaction. And looking at those, it will be able to identify whether the transaction is a case of double spend or not. Right. So that's why it just does uniqueness and not the validity. Now, that's just one phase of the coin. You have the other side as well. So notaries can also basically be non-validating notaries. So notaries are of two types. All these things that I've talked about is for non-validating notary, and that is generally the notary which people use. So there is a very little use of validating notary. People don't, but it is still there in case you have a particular use case where you want to have a validating notary. Probably for cases where you have a notary, where the notary is something like a governing body or a regulator who wants to have a look at everything that's happening in the network. So in that case, you could use that. So as the name suggests, validating notary will also go into validating your transactions, which is it will actually look at the content of the transaction as well. So two types of notary, non-validating and validating. Non-validating only does double spend check, and validating will do double spend check as well as your validation of your content of your transaction as well. Right. Now, notaries, that's the type of notaries. Now, your network could have a single notary node, or you could have a pool of notaries, right? So a single node is just a single node. You can refer to that node and say, just do this transaction. But you could also have multiple nodes and all of them being coupled together into a single service identity. So whenever you refer to this notary pool, you will say that I want to use pool A, and then the nodes in the notary pool will basically go ahead and come to the conclusion of whether the transaction is valid or not. Right. So this notary pool can run any consensus algorithm which is pluggable, and it could be as per the requirements. You could use any kind of algorithms that you want to. All right. So that's a bit about notary. Now I think we have questions here. So what made you think you use Java rather than other languages? All right. So so Java is basically the major language which is generally being used. If you look at the number of developers that are in Java, it's pretty high, which made us. And also, if you look at major or all the bigger enterprise softwares which are running on big organizations, so generally they use Java. And Java is the real tech which is being used for enterprise applications, which is generally the trend. It might change over time, but then currently we'll have to go with what the trend is. And so we chose to use Java as the language for developing our applications, developing the platform, and allow people develop their applications in Java as well, or for that matter, any JVM supported language. Okay, so the next thing is next question we have is who are the notary pools? How are notaries selected? And how is the conclusion between notary avoided? Okay, who are notary pools? Now, this is generally a question of consortium management. It depends on who you want to make sure, which identity you want to make a notary. So when you build your consortium, your network, basically you will all the parties who are involved in that will come to a conclusion depending on the governing model of your consortium. that who you want to make sure is a notary and how you want to select them. It's not a technical question, it's more of a business question. So generally, it depends on how you want to run your business and what are the different things that you want to look at while selecting your notaries. So basically, you can also say your business network operator to run the notary, or if you want to have a separate identity to run the notary. It depends on whatever ideas you favor it. And there could be multiple notaries as well. It's not necessary that you will have a single notary. So you could have multiple notary clusters. You could have multiple. So depending on which notary you want to choose, you could basically just go ahead and choose a notary. Does the notary have a charge? So generally, it again depends on how you want to do this. Generally, if you're using a particular um, if you use something like the Corda network, which is a global Corda network, there is no charge, but there might be cases where a notary is provided as a service, and it might, but generally it's not chargeable. But again, it's not a word which I can say that whether it's chargeable or not. Tomorrow there might be some consortium which comes up and then they say that we'll charge for the notary. It's up to the business how they want to run it. All right. All right, keep putting the questions there if you have any, and then let's move on to our Corda app section. This is where we develop how to develop our applications on Corda. So we'll learn about the platform a little bit, and then we'll go ahead and learn about the developing applications on Corda. So basically, Corda apps are the applications. Corda apps stand for your Corda distributed application, and whenever you develop a Corda app, you generally are looking at three different components. First is the state, which is your asset. So anytime you want to develop an application, it has to do something or do a transaction. So that would involve an asset. So you have to model that asset. To do that, you use something called as a state. And then to evolve that asset over time, you have to do transactions. You will change some state, some properties of that asset. So those changes have to be done through transactions. And these transactions have to go through a set of rules, like business rules, before that changes could take place. So these rules are written into something called as contracts. So every transaction has to run the business rules to validate that whatever changes they're proposing are valid or are contractually valid in terms of the contract rules. Right. And finally, you have the flows, which is more like the business workflow. These are like all the different sequential steps that you have to perform to perform a particular transaction. So which would include something like asking for necessary data from your counterparties and asking for signatures, and then getting the transaction notarized and committing on each and everyone's ledger. So these are different steps which you have to perform, and it's not very difficult. There are certain inbuilt APIs which will help you do this. You just have to write your own business logic, build your transaction properly, and then call certain APIs which will make sure that all the steps are taken care of by the platform itself. All right. So let's look at a Corda States. So Corda States is, so whenever you write a state, you have to implement a contract state interface that lets Corda know that basically this is a state and it needs to be persisted on the nodes database, right? So there are different types of states. So contract state is the base class, and then you have the base interface, and then you have multiple different interfaces which will help you model different types of states. I'll not go into the details of each of these, but this is for something. I'll just say probably just a single line about each one of them. So linear state is a state which is basically which doesn't no, which evolves in a straight line. So it's something like house. You can't basically divide it into two parts. But if it's something like cash, you could say 100 is equivalent to 50 and 50, right? So 250 is equal to 100. So that is what we call as fungible. So fungible is the one which could be split and merged. Similarly, you have ownable. Any state which could be owned by a particular entity at any point of time can be ownable. And then we combine fungible and ownable to make a fungible asset. Similarly, we have helper kind of states as well, like queryable state and schedulable states. So queryable state is the one which will allow you to basically put some or all parts or all properties of your state onto a separate schema, which is sometimes helpful for integration purposes or even for reporting. And then we have schedulable state, which will help you schedule events on the Corda node. All right. And we also have something called as a reference trait, which is also a pretty interesting feature. So suppose you have something like a master data where you have put, say, for example, say country codes, and then you want to refer to that. But as you refer, it means you have to go put it as an input, which means it will get consumed, and then you're not doing much with that state. All you're trying to do is read that state. You still have to consume it. So to get rid of those kind of issues, we have something called as a reference state, which is what you could add to a transaction, and then that state will only be referred or only be read, and it won't be consumed going forward. So that's reference state, which is pretty handy in most cases where you have master data. Right. So moving to contracts. So we talked about states. States are your assets. Now assets need to change over time, right? If it stays as is, it's not much of use. So to change them, you'll have to do transactions, which means once it's on your ledger, you have to pull that out of your ledger, make the update that you want to do, and then commit that transaction onto your ledger. So that's what transactions do. You put an existing state as an input, and your output is your desired output, which you want to whatever the changes that you want to do, and then that transaction will go through all the contract business rules. There are multiple rules. You have to make sure that all your rules go through and all of the rules are valid. And once that has been done, and these contract rules are validated by everyone who are involved in the network, then your transaction can go ahead and be recorded onto the ledger after the notary has given a go ahead. Right. So few notes on contracts. So basically, contracts need to be deployed on each and every node on the network. So basically, or each and every node that are involved in a particular transaction on a particular asset. So each of them needs to have that contract so that they validate the business rules by themselves, because nobody trusts each other in this kind of a blockchain or network scenario. So everybody will do their own validations. And so contracts are the one which will govern the evolution. Like we said, it has to all your transaction have to go to the contract, and it has to be valid as per the rules of the contract. Only then the states are evolved over time, right? So contracts have something else as well within them, which is called as a command. Now, if you look at this particular transaction, so transactions doesn't say what it's actually trying to do. When I say contract, it validates rules, but which rules exactly? So when I say a transaction of a vehicle, what exactly am I trying to do? What is the action that I'm performing? I might be doing a registration. I might be doing a service. So there is a command which will so this is the command in your command which will tell you what exactly is the purpose of your transaction. What is it really trying to do? And once you have the purpose, if it's registration, I can go ahead and run all the rules that are required to be validated for a registration of a vehicle. And similarly, if it's a service, I can do the same. So commands are also important. It indicates the intent of your transaction. And commands would have one or more signers, which would say who are really the required parties who need to sign on your transaction for the transaction to basically be completed. All right. So finally, we have our flows section. So flows are our, like we said, are the ones which help you finalize your transactions or run your transactions or run your business workflow. So here is an example of a very simple two-party trade where the way this works is initially you would have to propose your update. So this means that you create your transaction and then you check your update, which is where you run your contract rules. And finally, once you are satisfied, you can sign your transaction and then go ahead and send it to your counterparty. And the counterparty will repeat the steps where they will check the contract rules for the transaction. And if it's valid, they'll sign it again and send it back to the initiator. And then once the initiator is have the signed transaction from all the counterparties, you can go ahead and send this transaction to the notary pool where it will be checked for double spending, and it will come back to the node and be recorded onto each and every every individual or each and every node's ledger who are involved in the transaction. So that's how a simple trade works, simple transactions work. It could get a lot complex depending on what kind of transactions you're actually what kind of transactions you're doing, how complex your business workflow is. So this is a bare minimum or a very basic flow which you will require. I think we have a question. Let me just take that. Can Corda app support multiple assets? Yeah, you can have multiple assets in a single Corda app. All right, so this is how your Corda flow actually work. You just so this is the major thing that you have to do. You have to build your transaction, you have to verify, you have to sign, and then you have to record the transaction. So apart from that, so any sort of internal kind of things where you have to send the transaction to other counterparts and get it signed from them, and all these things will be taken care of by APIs, which you just have to call, and it will make sure that all your low-level tasks are taken care of. Right? All right, so let's just do a small little demo to understand how things really work. So what I have here is a simple token. If you look at the state, right, like I said, state have different properties onto them. So look at the state, it has an issuer and an owner and an amount. So this is a token state. So I have a token which I'll issue, and I'll be able to transfer this token to multiple different participants. So basically, these are the things which we could do. So I have an issuer who is the one who is going to issue this token, and then I have an owner, and then I have the amount of token that I want to issue. So similarly, if I look at the contracts, so this is all the rules that I have, just simple if and else statement. So I'm just checking. If you look at here, I'm just checking that the amount should be positive. So this is where I make sure that I'm not issuing any token which is of zero amount. So any token which doesn't have an amount is worthless, right? Why do I issue something? Or even if it's negative, you can't have a token which has a negative amount. What kind of token would that be? Right, so all these kind of validations. So just simple if and else statements, and you throw an exception if any of your rules are not validated correctly. Right, and then we have the flow. So like you see, we are building our transactions here. We have a transaction builder object, which the API provides, which will help you build transactions. So you're adding your inputs and output states. So there is no output for this one, for no input for this one, but there is output state. And then you're adding your commands. So basically, these are the things which you really have to do. Just building your transaction is the major part. Other than that, it's all like standard code, which is just like verify, which is go to your transaction. Or do your transaction get verified by the contract? So just call this API. This is standard code which you'll have to do, and then this is the one which will collect signatures from your counterparts. And
Ashutosh, is there a video that you're playing? I guess your screen is stuck on let's see it in action.
oh, right, sorry,
Yeah, no problem.
just a second. All right. Yeah, so this is the one which I was showing. So this is your flow part where we have the building of your transactions, and these are pretty much simple. I would say just your pretty much normal or template code which you will run to verify your. This is where you verify your transaction, which is where you call your contracts to verify the transaction, and then this is the one which will basically take care of collecting all the signatures from your counterparts, and then this is the one which will take care of sending the transaction to your notary, and then also recording it onto the ledger. And I also showed the contract code, which is just certain if and else statement. You throw an exception if you see that one of your rule is not getting validated successfully. And similarly, we also have a state, the token state, which has certain properties, just few properties, and some getters and setters, nothing much more than that. So let's just run this and try and see how it works. So we have 4 different nodes here. We have a notary, we have party A, we have party B, and we have party C. So it'll just take a few seconds for us to run this. So Notary is here, which is not much of our use other than it will just be used in the background to validate your transactions, but we'll use all the other nodes like party A, B, and C to issue our commands. So it basically logs you in as a default user generally when you do your development thing, but it won't really happen on your production nodes. You can type in help to see what commands are available for you. So all these are the commands that you have. What I'm really interested in is looking at what are the flows that I have installed. And if you look at this, I have the token issue flow and I have a token transfer flow. There are a few others flow which are like your inbuilt flows, which will be required for different purposes, but we're not concerned about that right now. So if you look at the token issue flow, what I'll do is I'll just run the token issue flow. And to run that, we'll just have to say start the flow and pass in all the parameters. So for me, the parameters are the owner and the amount. So I'm running this as party A. So party A is the issuer of this token. He's issuing this token. And then party B is the one who will be holding this token. And the amount of token that I'm trying to transfer is or issue is 100. So as I hit enter, you see that there are certain steps happening, which we have defined in the flows. And once your flow is complete, it will return you a transaction ID. Now, since I have done this, there has to be something recorded on the ledger, right? So I can go ahead and check my ledger using this particular command, which will say run vault query contracts. And then I say which is the type of state that I'm trying to query for. And for me, it's token state. And there you go. So we have this particular state, which we have recorded. We have an issuer A, we have an owner, and then we have the amount. So these are exactly the same properties which we have defined. Right. So we should also see the similar thing on party B node because party B was the one involved in the transaction. And you'll see the same. But party C would have nothing because he was not involved in the transaction. Now I can just go ahead and say transfer some of the tokens from B to C so that he also has some tokens. Right. So this is the transfer flow which I'm using, and you could see that the transaction has completed successfully. And if I go to party C now, he has 80 tokens which were just transferred. And if you go to B, he would have a little less now because he has just transferred some of them back. So you have 20 left, while the others have been sent to C. And A being an issuer, you should have a view of who has what. This is just the way it has been done. You might want to do this or you might not want to do this. So 80 is with A and 80 is with C and 20 is with B, right? So that's how you do your sort of build your simple applications on Corda. So we have talked about different aspects or different components which make your Corda which will be required to build your entire Corda app. So states, flows, and contracts. So generally, it's these are the three components which basically come together which come together to make an entire Corda app work. And once it's installed on your node, you can have the node give you all the flows that have been installed and then fire the flows to start your transaction. And once that flow is completed, your assets will be recorded, or the updates to your assets will be recorded on Relay Ledger. All right, so that's pretty much it from me for this one. Do we have any questions left?
I guess that's all the questions that we had. We have one more question, which I guess I'll post it to you. Not sure if it's relevant to your masterclass, but still.
Okay. All right, let me check out that final question. How can we use blockchain to fight against fraud and eliminate crime? That's well, for us, we don't if you look at public blockchains, like they use code as law, right? So but for us, we are in the business world, we don't use code as law. For us, law is law. So you can have your nodes audited, you can have all these things. So it will help you to perform business in a streamlined way, but we will not take care of the law aspect of thing. So for a business blockchain, we just allow business to do business more efficiently. But for a case of conflict, they'll have to go to the court of law, and everything is audited, everything is well there, and that's how you have to deal with any kind of issues on any fraudulent activities, you'll have to go to the court of law. What is the best tutorial to start the learning curve? Well, you could go ahead and start with just if you're a developer, basically you can go ahead and look at one of our boot camps, which will help you to get started. So we have, this is just a high level thing of what we have done today. You will have much detailed boot camp, which will just go through developing an entire application, live coding and stuff. So that'll help you get started. And then from there, you can basically then continue forward. We have the training side, which will also help you, which I mentioned in the beginning of the slides.
Great. Thank you so much, Ashutosh, for this great
Right.
masterclass. Thank you to all our delegates for being with us and being such active participants. Do stay tuned for such more exciting conversations. Thank you so much, Ashutosh. Have a great day.
Thank you. Thank you everyone for joining as well.